Have you ever gazed up at the night sky and wondered, what secrets does it hold? Every twinkling point above is a sun, each with its own family of planets, perhaps teeming with mysteries. Across the cosmos, observatories scan the heavens, searching for answers to questions as old as humanity. For centuries, our curiosity has driven us to explore, to ask if we are truly alone in this endless ocean of stars. But what if we've been asking the wrong question all along? What if the real mystery isn't about life in our universe, but about the universe itself? Could it be that our universe is just one among countless others? This isn't just science fiction, it's a bold idea emerging from the frontiers of modern science. Physicists and cosmologists are now exploring concepts that challenge everything we thought we knew. Some of the world's leading theories suggest that a multiverse isn't just possible, it might be inevitable. Imagine, our cosmos could be just one member of a vast, diverse family of universes, a true multiverse. This idea shakes the very foundation of our reality, daring us to dream bigger than ever before. We've always believed the universe was everything, every star, every atom, every moment in time. But new discoveries in cosmology, quantum mechanics, and string theory all point to a startling Mustang pagkapa saksi at stability. The laws of physics themselves may be hinting at realms beyond our imagination. Are you ready to explore? Let's begin with the most straightforward and perhaps most intuitive version of the multiverse. This idea doesn't require any new physics or exotic theories. It relies on just two simple and widely accepted concepts. The first is that space is infinite, or at least astronomically vast, far larger than the portion we can see. The second is that the distribution of matter and energy within that space is, on the largest of scales, roughly uniform. If you accept these two premises, then a startling conclusion becomes almost inescapable. Somewhere out there in the unfathomable depths of space, things must start to repeat. Imagine you have a deck of cards. There are a finite number of ways you can shuffle that deck. A very large number, but finite nonetheless. If you shuffle the deck and an infinite number of times, the exact same sequence of cards is guaranteed to appear again and again. Now, let's apply this same logic to the cosmos. The stuff in our observable universe, the particles like electrons, protons, photons, can only be arranged in a finite number of ways. Our observable universe is a finite volume of space containing a finite amount of matter and energy. Therefore, if space truly stretches on forever, it must eventually run out of new ways to arrange particles. Think of our observable universe as a single patch in a gigantic cosmic quilt. As you travel far beyond the edge of what we can see, you would eventually encounter other patches. Given infinite space, it is a statistical certainty that you would eventually come across a patch that is arranged identically to ours. This concept is often called the quilted multiverse because it pictures reality as an immense patchwork of cosmic regions. So out there, unimaginably far away, another version of you could be reading this exact sentence at this exact moment, living on a planet identical to Earth, orbiting a star identical to our sun. The laws of physics in these other regions would be the same as ours. And the only difference is that doon di siya initial arrangement of particles. Some patches would be wildly different from ours, perhaps containing no galaxies or stars at all. Others would be subtly different, a world where you chose a different career, a world where a single historical event unfolded differently. Every possible arrangement of matter that is consistent with the laws of physics would be realized somewhere. This means there isn't just one copy of you, but an infinite number of them. each living out a slightly varied existence. A rough estimate suggests you would need to travel a distance of 10 to the power of 10 to the power of 118 meters to find an identical copy of our observable universe. We are causally disconnected from these other regions, as light from them will never have enough time to reach us. We can never hope to visit them, communicate with them, or even confirm their existence through direct observation. Their reality is inferred, a logical consequence of combining the idea of infinite space with the finite number of ways particles can be arranged. The existence of these doppelgangers is a profound and unsettling thought, a cosmic echo of our own lives playing out across an impossibly vast stage. A second, and perhaps even more dynamic vision of the multiverse comes from our leading theory of the early universe, cosmic inflation. This theory proposes that in the first fraction of a second after the Big Bang, the universe underwent a period of hyperaccelerated expansion, swelling from a subatomic size to astronomical proportions almost instantaneously. Inflation brilliantly explains many observed features of our cosmos, such as its large-scale uniformity and its geometric flatness. A deeper analysis reveals a stunning consequence. The inflationary process, once it starts, may never completely stop. Imagine the inflationary process as a vast ocean of energy called the inflaton field that is constantly and rapidly expanding. Our Big Bang was like a single drop of this energy freezing or decaying into a stable state. This decay released a tremendous amount of energy, creating all the matter and radiation that formed our universe. Our universe then is like a bubble that formed within this ever-expanding inflationary ocean. The key insight of eternal inflation is that this bubble-forming process can happen again and again. The inflating ocean randomly sprouts new bubble universes, each one its own Big Bang. It's cosmic champagne. Our universe is just one bubble in an eternally fizzing foam. Unlike the Quilted multiverse, where other universes are distant regions of the same space, these bubbles are genuinely separate, self-contained universes. Each bubble could have different physical laws. The fundamental constants of nature could settle into different values: strength of gravity, mass of an electron, number of spatial dimensions. In one universe, gravity could be so strong it collapses instantly. In another, it could be so weak that stars never form. Our universe, with its fine-tuned laws, might be one day lucky bubble, one day among countless sterile ones. The space between the bubbles is still inflating at an exponential rate, pushing them apart far faster than the speed of light. The concept that each bubble universe could have different laws of physics offers a potential answer to one of the deepest mysteries in science. Why are the constants of nature so perfectly tuned for life? For example, if the force that holds atomic nuclei together were just a few percent stronger or weaker, carbon, the basis of all known life, could not be produced in stars. If gravity were slightly different, the universe would have either collapsed long ago or expanded too quickly for galaxies to form. This is often called the fine-tuning problem. The inflationary multiverse provides a natural explanation without resorting to a supernatural creator or sheer luck. If there are countless bubble universes, each with a random set of physical constants, then it is no longer a surprise that we find ourselves in a universe with life-friendly laws. It's a matter of selection bias. We could only exist in a bubble where the rules permit our existence. It's like asking why you find yourself living on Earth, a planet with liquid water, a breathable atmosphere, instead of on Venus or Mars. All the sterile universes are out there, but there is no one in them to ponder their inhospitable laws. This perspective recasts our universe from being a unique, miraculous creation into being a statistical inevitability. This idea, while elegant, remains deeply theoretical. We cannot directly observe these other bubble universes. They are causally disconnected from us, existing outside our cosmic horizon. Our third journey into the multiverse takes us from the cosmic scale down to the bizarre realm of the subatomic, quantum mechanics. One of its core and most perplexing principles is that before a particle is measured, it doesn't have a definite property like a specific position or velocity. Instead, it exists in a superposition of all possible properties at once, described by a mathematical structure called a wave function. The act of measurement seems to force the particle to choose one of these possibilities, and we only ever see one outcome. In the 1950s, a physicist named Hugh Everett proposed a radical alternative. He suggested that the other possibilities don't vanish at all. Instead, at the moment of measurement, reality itself splits. The entire universe divides into multiple branches, one for each possible outcome. In one branch of the universe, the particle is found at position A. In another, separate branch, an identical version of you finds the particle at position B. This is the many worlds interpretation of quantum mechanics. It means that every time a quantum event has more than one possible outcome, the universe duplicates itself. An electron in a superposition of spin up and spin down doesn't just choose one. When you measure it, the universe splits. This branching happens constantly, everywhere. It happens when a radioactive atom decays or doesn't. It happens when a photon hits your retina or misses, creating a near-infinite, ever-proliferating tree of parallel realities. Every choice you make, no matter how small, can be traced back to quantum processes in your brain. Did you turn left or right? Did you drink coffee or tea this morning? According to the many worlds view, you did both. One version of you is living out the consequences of turning left, while another version of you in a separate universe is experiencing the life that resulted from turning right. Our final exploration of the multiverse arises from the cutting edge of theoretical physics, string theory. It does so by postulating that elementary particles aren't point-like dots, but tiny, vibrating, one-dimensional strings. Different vibrations of these strings give rise to different particles, much like a violin string producing different musical notes. For the math to work, string theory requires extra spatial dimensions beyond the three we experience, length, width, height. Traditionally, they're thought to be curled up into a microscopic shape too small to perceive. A newer development, Brane theory, short for membrane, offers an alternative. It suggests our 3D universe could be a vast membrane-like surface, a brain floating inside a higher dimensional space called the bulk. All the particles and forces that make up our world, except gravity, are stuck to this brain like characters on a sheet of paper, unable to navigate to move into this higher dimension. This opens the door to a new kind of multiverse. Our universe brain might not be the only one. The bulk could be filled with other brains, each a parallel universe. These brain worlds could float just millimeters away in a higher dimension, yet remain completely invisible and inaccessible. Gravity is unique. Not confined to our brain, it can travel through the bulk and allow potential interactions between universes. If another brain collided with ours, the impact would be cataclysmic, releasing energy enough to trigger a Big Bang. Some physicists even propose our Big Bang came from such a collision. A weak gravitational pull from a nearby brain could have subtle but detectable effects on us. High-precision gravity experiments, particle accelerators like the Large Hadron Collider, which could theoretically create particles that briefly escape our brain, and vanish into the bulk. Stationary deep space animation serving as a title card backdrop. We have journeyed through 4 compelling yet profoundly different pictures of a multiverse. The Quilted multiverse arises from the statistics of an infinite space. The inflationary multiverse envisions an endless foam of bubble universes with varying physical laws. The quantum multiverse proposes a constantly branching tree of parallel realities. And the Brane world multiverse imagines parallel universes as membranes floating in higher dimensions. Each idea, while sounding like science fiction, is serious bisotis horodian what it is dapizui sopa so is possibility rooted in the mathematics of our best physical theories, but are they true? At present, we simply do not know. The central challenge: most other universes are beyond our ability to directly observe. Quilted, distant patches are too far away. Inflationary, other bubble recede faster than light. Quantum, parallel worlds occupy a different branch of reality. Brane worlds, hidden in extra dimensions. Some critics argue the multiverse is philosophical rather than scientific, not definitively falsifiable. Science, after all, relies on testable predictions. However, the situation is not hopeless. Physicists are exploring indirect evidence. A search for cosmic bruises or cold spots in the cosmic microwave background could provide a tantalizing hint of a past collision with another bubble universe. Add the Large Hadron Collider, detection of particles that seem to vanish. The creation of miniature black holes, possible evidence of extra dimensions. Refining measurements of the fundamental constants could tell us if values fit a single universe or the statistical distribution predicted by a multiverse. We stand at a remarkable moment in the history of science. For the first time, we have concrete theoretical frameworks that suggest our universe is not the only one. The ideas of a quilted cosmos, of bubble universes, of branching quantum realities, and of Hayavishinki Dai Avorati Anafan Kuti Ausantangos as Ba Kuti Antin Anistos, showcasing the lesson that will challenge the finality of our cosmic home. They collectively paint a picture of a reality far grander, stranger, and more expansive than anything our ancestors could have ever conceived. We have been demoted time and time again from the center of the universe to a small planet orbiting an average star in an ordinary galaxy. The multiverse is the next and perhaps final step in this cosmic humbling. These theories, while unproven, force us to reconsider our own significance. If there are infinite copies of you in a quilted multiverse, what does that mean for your individuality? If our universe's life-friendly laws are just a lucky roll of the dice in an inflationary multiverse, does that diminish the wonder of our existence or enhance it? If every choice you make splits the universe in two, what does that say about free will and consequence? These are not just scientific questions. They are deeply human ones that touch upon philosophy, identity, purpose. For now, we remain inhabitants of this universe, bound by its laws and limited by its cosmic horizon. The other worlds proposed by these theories are, for the moment, beyond our grasp. They exist in the elegant equations of physicists and in the powerful simulations run by supercomputers. They are phantoms of possibility, whispered by the mathematics that so successfully describes the world we can see. But science is a process of turning whispers into shouts, of turning mathematical possibilities into observable realities. The search for evidence will continue, pushing the boundaries boundaries konda asawa ko po na bapawista da Arentaurogen theory. Is the universe we know the beginning and the end of reality? Or is it just a single lonely grain of sand on an infinite cosmic shoreline, one of an endless number of worlds, each with its own story, its own laws, and perhaps its own life. Ultimately, the quest for the multiverse is a testament to humanity's drive to understand our place in the cosmos. These theories were forced upon us by the logical progression of our best scientific models. If inflation or string theory keeps making successful, testable prediction about our universe, we must take their other prediction, including a multiverse, more seriously. The evidence may be subtle and difficult to obtain, but the search is underway. The discovery of another universe would forever change humanity's perspective on reality. What would it truly mean for us, for our understanding of everything, if we were to find out that we are not unique, that our entire cosmos is just one of many? The answer, if we ever find it, what will undoubtedly be the greatest paradigm shift in the history of human thought. Animated scientific visuals over subtle cosmic backdrop, calm pacing, warm cosmic gradient with subtle stars, inviting end screen feel, space themed end screen with room for subscribe button and thumbnail, slow fade out on starfield and nebula as music gently resolves.